important beta. So I have started with standard enthalpy only, but we have completed that phase transformations. Now again, we're coming back to what? The standard enthalpy of formation. In the previous classes, what we discussed beta? Enthalpy of reaction, right beta? Enthalpy of phase transformations we have completed. Now we'll see the enthalpy of formation beta. Then we'll see the equation also. So in this topic, what we are discussing now? Enthalpy of formation. Now tell me, what is, anybody knows what is the formation means? What we have to take here? Formation means what happened? For example, methane is forming. Methane is forming. CH4. How it form beta methane? By using what type of elements it will form methane?
Carbon and
2 moles
hydrogen.
of hydrogen. What are the constant elements beta? What are the constant elements for formation of methane? What are the constant elements for formation of methane beta? Carbon and hydrogen. Correct? So how do you make definition here? Very simple. The change in the enthalpy. If you say change in the enthalpy means energy may be absorbed or energy may be released. Both we can say. Instead of saying what happened, energy released, energy absorbed, you can say also like, if you don't know that process is an endothermic or exothermic process, you don't know that. In that case, you say what happened? The change in the enthalpy. You say if the change in the enthalpy, it may be endothermic or it may be exothermic. So the change in the enthalpy when 1 mole of a compound, see how many moles it is formed? Only 1 mole of a compound is formed from its constant elements. Its constant elements are nothing but carbon and hydrogen. Okay. So that enthalpy change at given conditions is called what? Given conditions means standard conditions is called what? Standard enthalpy of formation. Now in this case, if I write like this here, if I write like this, carbon, if I write like this, carbon plus oxygen gives rise to carbon dioxide. If I write what happened, carbon monoxide plus oxygen, half oxygen gives rise to carbon dioxide. This one is called enthalpy of formation. Okay, this one is called again enthalpy. Can I call this one enthalpy of formation beta? Can I call this one enthalpy of formation? This one, third one. Can I call this one enthalpy of formation beta?
No, sir.
No, sir.
No. Why? What is the reason?
So because 1 mole of O2 is not reacting.
There also 1 mole is only, no? So I told you from its constant elements, I told you. From constant elements, I told you. Now this is not element beta. This is what a molecule. Now you can call this one half oxygen converting into CO. You can call this one enthalpy of formation. You can call that one. It must be found from the constant elements, but not from other molecules. Of course, it is also molecule only. You can say hydrogen is also molecule only, but it is a constant element. The molecule is made upon by the constant element only. But the molecule is made upon by what? Carbon plus oxygen. You can't take this enthalpy of formation. So that type of questions also you may get in MCQs here. Following which can be taken as enthalpy of formations. Like that you will get that. Now let me take again definitions. I told you the definition. Let me see again. The change in the enthalpy, the standard enthalpy change. Otherwise, the change in the enthalpy. The change in the enthalpy. For formation of 1 mole of a compound. For formation of 1 mole of a compound. From its constant elements. Or from its elements. Or from its constant elements. In the stable. That should be stable beta. Whatever should be stable state. It's called standard enthalpy of formation. Because you are taking what standard conditions. If it is standard conditions, this is called standard. Very simple, no? If it is lengthy, what happened? Please, if it is lengthy, what happened? You can remember like this. Very simple it is. The enthalpy change for formation of 1 mole of compound from its constant elements in standard conditions is called standard enthalpy of formation. Very clear, no? Everyone? Any doubts regarding this one beta?
No, sir.
Enthalpy of formation beta? Yes or no beta? Say yes or no, beta. Now you see, minus 285.8 is now called as what? Minus 285.8 is called what now? Tell me, beta. What is minus 285.8?
Exothermic reaction.
Right. What is the meaning of minus 280. That is exothermic beta, correct only. But what is the meaning? If I write minus 285.8 means in terms of words, what you understand?
That much amount of energy.
Vaishnavi N or Vaishnavi J? Are you there, beta? Vaishnavi N or Vaishnavi J? Now tell me, beta, what is the meaning of this one, beta? Minus 285.8 means what? If you say this one, I think you understand everything. The meaning of minus 285.8. Vaishnavi N or Vaishnavi J? If you don't speak what happened, I will put absent. It indicates that you are not present in the class. You can speak, no problem. Whatever there in the screen also you can speak. I am not asking that you have to compulsory tell correct answer. Just you have to interact. Tell me better, do fast. Yes, beta. Shall I put absent Vaishnavi N and Vaishnavi J? Both are absent? Right. Okay, I have kept absent.
Sir, excuse me.
हाँ बोलो बेटा.
Sir, I'm present. Sir, Shashidhar.
हाँ बोलो बेटा. शशिधर बोलो.
Sir, I'm present.
I know. I didn't say what absent. Did I say absent? Shashidhar is absent. अभी आप नींद में आया ही सो रहे हैं आप. I'm not taking the attendance beta. That means you are sleeping in the class. Shashidhar, are you sleeping in class now? Otherwise, you came now.
Sir, I misheard it, sir. Sorry.
This is actually, I recently I watched a video on YouTube. On that YouTube, what happened? Online class start going on. Suddenly, what happens? Some students say, "Sir, I am present." Actually, the teacher is asking question. In that video, I watched that video. Teacher is asking question. Suddenly, that student said, "What happened, sir? I am present." Same thing is happening. Yesterday only I watched that one. Same thing is happening today. I have asked a question that you are saying, "What happened? I am present." Is it coincident? Otherwise, general is happening. Shashi Ranjan. Shashi Ranjan is there, beta? Shashi Ranjan.
Excuse me, sir.
हाँ बोलो बेटा.
So it is an change. It change in heat, and it is an exothermic reaction.
Your name, beta? What is your name?
So Vaishnavi Zadav.
Vaishnavi Jadhav. You just why you are responding late?
So there was some network problem. My mic was stuck.
Okay, beta. So actually, there is a problem is that if I ask questions, what happens? I can't complete the syllabus. One thing is there. If I ask frequently questions, I cannot complete the syllabus. Right? Without questions, what happens? In 1 week, we can complete the chapter. But if you don't ask any questions, what happens? It looks what happened. What? Only storytelling. Storytelling. Because in storytelling, nobody asks the question. Just they listen. Right, no problem, beta. We'll see here because the definition is important. Let me see now. Now, what is the meaning of minus 285.8? Very simple, based on the definition. For formation of 1 mole of water. In the formation of 1 mole of water. Understood better? In the formation of 1 mole of water. In the formation of 1 mole of water. From its constituent elements, from hydrogen and oxygen. from its constant elements means from hydrogen and oxygen. When the heat is released, that heat is what? 285.8 kilojoules. The heat is 285. That means in the formation of water, 1 mole of water, 285.8 kilojoules of heat will be liberated. And this heat we are calling as what? Standard enthalpy of formation. So if you remember like this will be simple for examination point. It will be simple. We'll take one more example also. One more example also. Nitrogen plus hydrogen gives rise to ammonia, right? So for getting 1 mole of ammonia, how much I have to take beta? 1/2 I have to take. Here how much I have to take here? 3/2 I have to take. Correct? So 1 of nitrogen, 3/2 hydrogen. If I take, I will get 1 mole of ammonia. In this case, the delta H value will be minus 46.1 kilojoules per mole. Okay. So what is this meaning of minus 46.1? Anybody know? The meaning of 46.1 minus. What's the meaning of that one? Wait.
So to form.
This much amount of heat is liberated when 1 mole of compound is formed.
Very good.
One is constituent element.
Very good. For formation of ammonia, 1 mole of ammonia, this much amount of heat will be liberated. So right onwards, what happened? From coming chapters, what happened? We write the equations like this one. Coming whatever the slides we discussed. So indicate it is this much amount of heat is released in the formation of 1 mole only. Okay, right. Next, chemical reaction involves energy change. This is already, you know, whenever a chemical reaction is taking place, energy will change, right? Now, but when you observe what happened, there will be some steps. If you consider reaction, there must be some steps here. Let me take combustion of alcohol. So what type of example I am taking? Combustion of alcohol, burning the alcohol in presence of oxygen. So any combustion reaction beta, if you see any type of combustion reaction, whatever combustion reaction of any molecule, you will get what? 1 or 2 products. If you don't have hydrogen in the given compound, here you are having hydrogens. If you don't have hydrogens, you will get carbon dioxide. If you have hydrogens, you will get the water. Except these 2 remaining, you don't get anything. If it is hydrocarbon. So hydrocarbons, isn't it, will definitely produce hydrocarbons, even though if you don't have oxygen also. They definitely produce carbon dioxide, water. So in all combustion reactions of hydrocarbon, the products are nothing but carbon dioxide and water. It's a thermal chemical equation. Now it takes place in step 1. How? Equation must be balanced. See, is it balanced equation? Tell me better. It's called balanced? No. I have to balance this one. How to balance this one? First, you have to balance the carbon. 2 carbons are there. Here only 1 carbon is there. Put here 2 there. Next, after that, how many hydrogens are there here? First, you have to balance the carbon. Next, you have to balance the hydrogens. How many hydrogens are there, beta?
6.
6. Here, how many are there here?
6.
2 only. Yes, so write down here 3 to the 6. Now, carbon is balanced, hydrogen is balanced. Next, you have to balance the oxygen. Now, you have to go, don't balance on left side beta. That means you have to balance by considering the right side here. Right side means this one. 3 here. And here how many beta? 2 to the 4 here. So 4 plus 3 is equal to 7. Here 2 to the 4, here 7. So take here 7/2 beta. 7/2 is equal to 7. Because 2 get cancelled, we will get 7 oxygens. Now equation must be balanced first of all. When you are writing the thermal equation beta, whenever you are writing thermal equation or thermochemical equation, you need to balance the equation first of all. Understood? Now it is balanced here. Now it is how much you got beta? 2 carbon dioxide, 3 moles of water. How many you got here? 1 more oxygen is there also there. No, sorry. Here 1 more oxygen is there now beta. Just now see what. Here 2 got. Here 5 plus 1, 6 we got, 3 to the 6. Now I have taken what, how many beta? 4 plus 3, 7, no? 7/2 I have taken, no? Correct or not? 3.5. Correct or not? But already 1 is there, no? So how much I have to take now beta here?
So 6/2.
6 by 2. 6 by 2 I have to take. Because I need 7. But already 1 is there here. So 6 plus 1, 6 by 2 plus 1 is equal to how much here? 7 only we get. So take 6 by 2. 6 by 2 is how much beta? 3. So we get here 3 oxygens. Right? So this is a balanced equation. Correct or not? After that, second step, what we have to do? Physical state we have to represent. Alcohol. Generally, alcohol, ethyl alcohol in the liquid state only, because you have seen spirit.
Liquid.
Spirit is liquid state only, right? Gas, oxygen is a gas molecule. Next, carbon dioxide, gas, you know that one. And water is
Liquid.
liquid state.
Liquid.
Now you have to write the liquid state. So step number 2 also completed. Next, value of delta H must be mentioned with, third step I am saying, the value of delta H must be mentioned with appropriate sign on right hand side. Here only I have to mention it. Here only I have to mention that. Delta H. Now remember bit, already you know, I know that one, you know. If delta H is negative, exothermic process. If delta H is positive, endothermic process. Here important thing what I am saying here. Now this 1430, if I write 1430 here, 1430 kilojoules. You are writing delta H equal to minus 1430. Now tell me, this is, if I write plus 1430 like this, is it called endothermic or exothermic reaction?
Exothermic.
Exothermic only. Because most of students, they are getting confused here. Sir, you told me delta H is negative, exothermic, but you written here plus, no sir. So plus means what? Endothermic? No sir, it will be endothermic. Is it correct? No. So don't get confused beta here. If you write here plus, it is not delta H value, not beta. It is not delta H. Delta H separately you are writing here. Separately you are mentioned delta H is equal to minus 1430. You are mentioning separately that one. But in the case of this one, if you write like this, here on product side, carbon dioxide released, water released, and this much amount of heat is also released. Okay. Now, if I write same thing here over like this, here I am writing. Here I am writing. Minus 1430 kilojoules. If I write like this. Now, is it called endothermic or exothermic beta?
Endothermic.
Same thing beta, exothermic only, no change. Why? Because remember beta one thing, if I change any molecules over here, it becomes minus beta. If I write anything plus 143 or 1430 kilojoules, plus if it comes here, it becomes what? Minus only, no beta. Correct or not? In any equation, for example, you are writing something, ax square is equal to bx plus c, you are writing something. If plus c comes here, it will convert into what beta? Ax square minus c is equal to bx. Correct or not beta? Same thing it is. Exothermic only it is. It is not endothermic beta. Understood? Correct or not beta? So,
Yes, sir.
Don't get any confusion over here, right? Right. Compulsory is in step number 3. You have to mention delta H with value so that whether the reaction is exothermic or endothermic, we can easily identify. By seeing this one, we can easily get it is what? Exothermic reaction. If delta H value is positive, then what happens? It will be endothermic. If delta H is negative, it will be exothermic. So that we can, by seeing that expression, chemical expression, equation, we can easily know what type of reaction. Next, after that, finally, the reaction conditions are not mentioned. Nothing is mentioned here. Here, did anything mentioned here actually? Anything is mentioned here? No mention. So in that case, what happened? The conditions must be 298, 1 atmosphere, nothing but what? Standard conditions, right? So if they mention like this, standard conditions. Generally, delta H naught is mentioned, isn't it? There what happened? That means delta H means any condition better. Delta H naught will be standard conditions. That should be better. This is no need for us. Delta H of forward reaction, reverse reaction is not. Actually, I will explain you. Now, what is the difference you are observing beta in these two reactions? What type of difference you are observing beta? What difference you are observing in these two conditions?
Sir, reverse secondary is reverse.
The reaction is reverse. When reaction is reversed, delta H value also will be reversed here. Now if this reaction, you know, this one is exothermic. Now this will be becomes endothermic reaction. If it is exothermic, this will become endothermic. Okay, for example, just now we have taken hydrogen plus half oxygen gives rise to water. In this case, delta H is equal to negative, that is something around 150 something you got it. Now reverse, if you take dissociation of water into hydrogen plus oxygen, always will be what? Positive. So if forward reaction is positive or endothermic, then backward reaction of same will be what here? Exothermic. Reverse to that. This is very, very important beta. Very important beta. Correct? Everyone knows? Right. Enthalpy of an element in its standard state considered to be zero here. This is also important for us. What is the meaning of this one? Let me state. Standard state, enthalpy of element can be taken as zero. For example, what is the enthalpy of hydrogen if they ask? Enthalpy of hydrogen. Zero only. Enthalpy of iodine. Zero only. Because iodine elemental state only. Because iodine available in I2 only. Isn't it? Hydrogen available in H2 only. But enthalpy of methane will not be zero. It will not be zero. Why? Because it is a molecule formed from certain type of elements. In that case, some amount of heat will be exchanged here. For the formation of methane, some amount of heat is exchanged. But hydrogen natural element it is. Isn't it? So in this case, what happened? There is no heat liberating, absorbing. Understood here? So for any element, if you observe, the standard enthalpy of that element in standard state taken as what? Zero. Standard state means conditions are standard. Temperature and pressure is standard conditions. What is the answer, beta?
It's a negative of reverse.
This one will be better. It's very important.
Zero.
Zero.
Now let me take.
Excuse me,
Yes, better.
sir. Our bio class is there at 10 a.m.
Today 10 a.m.
Yes, sir.
Okay, beta. You can leave now. How many are there?
Sir, 5 students.
All are present now. All are present. Let I check. Akruti,
Present, sir.
Bharati,
Present, sir.
Pallavi absent. Right. Swastika,
Present, sir.
Tejaswini,
Present, sir.
Tejaswini. Right. Okay, beta. You can leave. You can leave, beta.
Thank you, sir.
Thank you, sir.
Right.
Thank you, sir.
HESLA we'll discuss tomorrow, beta. This HESLA is a very important beta. We'll discuss. It takes something half an hour time. So we'll discuss tomorrow. So by day after tomorrow, by Saturday, we can complete. I will try to complete the remaining portion. Right. So today, whatever topics we got, there are definitions only. Enthalpy of whatever, something what happened, fusion, enthalpy of vaporization. They're all what actually definition. After the completion of the HESLA, again we'll discuss again enthalpy of combustion, enthalpy of atomization. These also definitions will come, right? We'll take attendance now. Abhishek Sharma, absent. Abhishek Y. Aditya,
Present, sir.
Anuj absent. Anushka,
Present, sir.
Ashif,
Present, sir.
Adarva,
Present, sir.
Atul, Ayush,
Present, sir.
Almukund, Chaitanya,
Present, sir.
Deepta absent.
Sir, present.
Gulabi,
Present, sir.
Alpesh,
Present, sir.
Kaushal,
Yes, sir.
Kunal,
Present, sir.
Manoj,
Present, sir.
Mayur,
Present, sir.
Ojas,
Present, sir.
Omkar M,
Present, sir.
Omkar C,
Present, sir.
Prathamesh, Samiksha,
Present, sir.
Present, sir.
Raghav,
Present, sir.
Raj,
Present, sir.
Ramya, absent. Ria,
Present, sir.
Rohit,
Present, sir.
बेटो 2 मिनट बेटो. Ria, present. Rohit,
Present, sir.
Sahil absent today also. Samruddhi,
Present, sir.
Sarthak, yesterday absent. Sarthak,
Sir.
yesterday absent.
Sir, I was out of station.
Shishidhar,
Present.
Shishidhar, Shashiranjan, present.
Present, sir.
Shashiranjan. Sneha, G. Sneha,
Present,
VS.
sir.
Sonali,
Present, sir.
Srihari,
Present, sir.
Sumit, M.
Present, sir.
Sumit, D.
Present, sir.
Suraj, C. Absent. Suraj, U. Priyambak, absent. Umesh, absent. Vaishnavi, J.
Present, sir.
Vaishnavi, N. Vaman,
Present, sir.
Vedant, Vishal,
Present, sir.
Yash. Okay, beta. You can log out now.
Thank you, sir.
Present, sir.
Thank you, sir.
Thank you, sir.